Hi guys, this is Mike Bull. I'm just putting a real quick video together because Mr. Thrive and Survive did a live stream today and talked about some experiments we did this weekend, and it's hard to picture it without visuals. I recently did this video, Sun and Moon Angles Part 2. You can watch it if you want to get the full breakdown, but the gist is, in the heliocentric model at new moon, peak new moon, if you imagine this red line as a plane that dissects the Earth from North Pole to South Pole and dissects the Sun, well, the moon in its orbit, at some point during the month, the same plane will dissect it. That is the moment of peak new moon. Okay, and we're told that at new moon, the moon rises with the sun and sets with the sun. And what that means, not for everybody, but for a person that happens to be right here on the terminator line at the moment of peak new moon, if he could see the new moon, he wouldn't be able to see it, but the moon is rising as the sun rises for him. And the guy down here, the moon and sun are setting together. And to just give you a quick idea of that, this is Perth, Australia, May of 2019, just last month. On the 5th, we had the full moon, or the new moon, I'm sorry, peak new at 6:45 a.m. The moon rose there at 6:49, so within 4 minutes, and the sun rose in Perth at 6:50. So everything within 5 minutes. Sun, peak new moon rising with the sun. Okay, so I've got this loaded up in Stellarium. I've got the atmosphere turned off so you can see the sun and the moon, and that's what this looks like. So remember, it was at peak new moon at 5:45 their time. So 5:45, we've got sun and moon rising together. Okay? My point is that you can't have that because the guy that's standing up here, the angle that he can see the moon is much steeper than the angle that he can see the sun, because the sun is 400 times farther away. So how could they both rise together for him or set together for this guy when they're at incongruent angles? Okay, so basically, I was saying that here's the Earth, the moon, and the sun all lined up in syzygy, they call it, when it's all direct in a line like that. Okay, and then the guy up here, he's standing right at the terminator line. Now, when he looks out on his horizon and he can see half of the sun, as half of it is, this half down here is below the horizon, and the part above the red line, he's starting to see it. He's starting to see half of it. He can't see the moon yet because the moon is way below his field of view. Conversely, if he could see at this steep angle and see the moon as it rises, well, the sun's already way up in the sky for him. Okay, so I got a whole bunch of comments about, well, you didn't put it to scale. You got to do it to scale. Well, guess what? You can't do it to scale on a computer. If you made the moon a single pixel, the sun would be 15 computer screens away from it. There's no way you can scale this ridiculous model they've told us on a single screen and still be able to see all the objects. Okay, so Rich and I decided we'll go out and do a real world experiment that is to scale. So the black lines here represent a street curve. It's a straight street, and what we did is we drew a 1-inch diameter Earth, and since the moon is supposed to be a quarter of the diameter of the Earth, we drew a 1/4-inch diameter moon. All right, and we put the moon 30 inches away from the Earth because the moon is supposed to be 30 Earth diameters away. And then the sun, at that scale, the sun is 400 times farther away than that. So that works out to 12,000 inches or 1,000 feet. So we went way down the street and we had our sun 1,000 feet away. Okay, and this is what that looks like. Let's see if I can find the right one. I think this is what I want first, just to show you. Okay, here's our curb. It's 6 inches wide, and it runs straight down this street for about 1,500 feet. Okay, there's our 1 inch Earth, and that little dot right there is our 1/4 inch moon. Okay, so then let's see here what I got. Try to see which one we did first. We first tried, we tried with this heavier rope that I had. It was pretty heavy duty because we figured we need something that wouldn't break, because I mean Rich is way up there, and the idea is we're going to pull this taut, and then we're going to keep moving until that string passes the moon. And I guess I should have showed first. So there's our moon, and this is not a good view. You can't see the Earth. Hold on. Let's see. But you can see I'm going up and down the curb because it's so heavy of a string that Rich couldn't pull it taut enough just to even make the line up. So we're trying to put it in there. Okay, this is what I was going to show you. We put a bolt on top of the Earth, so it's that guy standing on the terminator line, and he's the guy at new moon that's going to see the moon, half of the moon in his view, and half of it's below the horizon, and he's also going to see the sun, which has to be on this curve too, according to the heliocentric model. My point is, by the time we swing that string to halfway through the moon, that sun, it's got to be way out here in the middle of the street for him to actually see them both together. If the sun is where it's supposed to be up here, then by the time he can see that moon, that sun's way up in his sky. Okay, but anyway, the string did not work. You see Rich way up there holding the other end of it, and we just couldn't. Look at that happy guy. We were out there, it was like 105 degrees. Crazy. But anyway, we just couldn't. He's trying to pull it the best he can, and we just couldn't get it tight. It was too much. So then we tried fishing line. This is our fishing line, and we knew it was going to break, eventually. So this time I was up there doing the pulling, and you can see me. I'm standing right here next to the car. You can barely see me, but if you see that little object, that's me. We started over here where the sun is on the curb, and then I kept walking out trying to make, and then Rich is down here trying to tell me when that line crosses the moon. But again, I wasn't pulling it tight enough, and I didn't want to overdo it, but by the time here, I'll just let it play. Watch what happens here.
Oh, it broke.
So right when it started to, right when I got it taut enough that it started to, see how it's moving right here? Watch on the moon. I finally got it to where it was doing what we wanted to do and cross the moon, so we could tell where the sun would have to be, which would be out here somewhere. It broke on us. All right, so we tried this black thread that I had. I think right here, yeah. So this little thin thread, we got rid of the fat rope. That was the first fat one that didn't work. Although I did go out a little bit and make it work for a certain distance, but I'll show that later. Rich put a pebble on top of our little 1/4 inch moon because he was having a hard time seeing it in the camera. It was a bright sunny day. But anyway, it didn't work. So what we did, we took the big string off, and then we put this little thread on. Now, I kept on going back. I'd go back a little bit, and then I would swing it. Watch the thread cross the moon here, just to get an idea. So first I'll line it up on the curb. Just trying to get the fat string out of the way first. Well, I didn't think we'd be watching this much of it. Come on, man. Okay, so here I am. I'm lining it on the curb, and you can see right here. Let me pause this for a minute. see how the moon is? So if this guy is actually looking at the sun, and this is only, we need to be 1,000 feet away. I think this one was about 200 feet, maybe 150. Okay, but that moon, it's like 2 moon diameters away from being seen at the same time the guy's seeing the sun. But now what we'll do is I'm going to swing out till Rich tells me it's halfway through that moon, and we'll see how far out in the street I am.
Yeah, he's right on the sun. I'm going to zoom in for a second.
Okay. Tell me when I'm cutting the moon in half.
So now I'm just working out into the street. You can see the thread moving.
Now.
Okay, so right now our Mr. Bolt guy is seeing the new moon rise. Okay, and look how far off I am. The sun has to be centered on this curve too, but for him to see it,
Yep, that's
it's
how
got to
far
be
you're
that
off
far away.
already.
Now I finally got the thread. The max I could go was 500 feet, so half the distance. So that's this one right here. Okay, there I am at 500 feet.
And let's come in. See how far off it is.
He's gonna take a second. There we go.
Okay, go ahead.
Okay, so we're off of the moon. We're on the sun. We're off the moon. But now as I'm moving out into the street, he's going to stop me when it's halfway through. Okay, now he's going to show how far out in the street I am.
Look how far.
You see how far I am? This is where the sun has to be in the heliocentric model. But that's where it has to be for the guy to see both of them at the same time. Okay, that's only half the distance. Anyway, that's as far as we could go without breaking the thread, because the farther I went, the harder I had to pull, and then it would finally break. Then Rich came up with the very brilliant idea of using my laser. And so we came back later that evening, and that's exactly what we did. Instead of a string, I just put the laser right over the top of this bolt, and I shined it through the middle of the earth. And then we sent Rich way down here with the white board and had him I got the laser shining, and then he walked out until he had the laser centered on the board, and then he made a mark on the street so we could measure where it is. But that's how this went. Again, I'm just kind of explaining it here. And you can see here, you can see how far Rich is down there. So he's way down at the end of the street.
Mr. Thrive and Survive right there. And he is getting ready, but right where he's at, that's how far down the curb. You see him walking there. That's how far down the curb this sun is in the heliocentric model. We've got
That's ridiculous, isn't it?
Earth, so we got
okay, so I'm just explaining what I've already explained to you. So now we'll get to, okay, so now I'm putting the laser on top of the bolt, and I'm gonna, it's hard to hold it steady, so I go back and forth a few times, but you'll be able to see it halfway cutting through the moon here.
You can see half the moon. Car figures. If you can see half the moon rising, or setting, then he also should be able to see half the sun setting. But remember, the sun is way down this curve, way down at the end of this curve on this line, okay? So let's put this guy on the moon the best I can. Okay, so I got him halfway on the moon. All right, Rich. Okay, you got to walk out into the street a little.
So you can see the laser beam up here.
You see, I don't know if you can see Rich. Right
Okay,
there.
and then there's Rich. You can barely see him with his the white board. He's just lining himself up while I got this centered on the moon right there
Okay.
and trying to hold it steady, which was hard.
Hey, Rich, look at the front of the board and make it line up with the laser. Hold on. Oh, okay, I'm good now.
Now we noticed that during this experiment, we noticed that the laser goes much farther than 1,000 feet. So we're going to do it again with the laser. We'll have to find a farther, a longer straight street or a place so that we can do it for a longer distance. Then we can get to maybe a 2 or 3 inch earth you know, and a half-inch moon and just show everything better because, I mean, quarter-inch moon, that sucker is so dinky. But anyway, this is to scale. He is walked straight out from where the sun should be in the heliocentric model. And then you can see the beam is hitting him, and right there the beam is halfway through the moon, and it's hitting his white board.
Rich is going to mark where his feet are, and we're going to measure how far off
The actual sun. All right, you good?
Okay, so he's just got a piece of chalk with him, and he's going to mark it. There's his white sun. We went up to where he was.
farther up the road.
And there's my pink line where I measured it earlier in the day to the 1,000 feet.
X marks the spot where he was standing.
So that's where the mark was, and we brought the tape measure out. And there's my 1,000-foot mark from when I marked it earlier
From our 1-inch earth, so.
in the day. And long story short, tape measure is only 25 feet, so we stretched it out to 23, marked that, and then stretched it out again, and got another 8 feet of it. So
We have
minus an inch, but close enough. So 31 feet.
So it's really like 8 feet minus an inch, but we'll call it 23 plus 8, 31 feet off.
Guys,
So,
that's it for now. There'll be more and better coming soon.